Okay, in this video we're doing Calc AB Problem Set 71. The problems and a link to playlist are in the description below. Alright, let's do this. Number 1, evaluate the integral of x over the square root of 1 minus 9x to the fourth. So like your first thought might be just straight up u substitution, let u equal 1 minus 9x to the fourth. But then du would be negative 36x cubed dx, and we just don't have x cubed to deal with in the numerator there. So that can't be what we're dealing with. My next thought is what has a radical in the denominator? Arc sine, right? And the way that you think of arc sine is probably as just 1 over, the derivative of arc sine is 1 over the square root of 1 minus x squared. This kind of looks like that. So if that's the case, then 9x to the fourth should be like u squared. So u should be 3x squared, which would make du 6x dx, but we're going to bring the 6 over and we'll have 1/6 du is equal to x dx. So we can replace x dx with 1/6 du, and then it'll be the square root of 1 minus u squared. I'm going to pull the 1/6 out, because that's what we do with constant multiples. We have du over the square root of 1 minus u squared. That's definitely arc sine. So we now have 1/6 arc sine of u plus c. And then we know u is 3x squared. So 1/6 arc sine 3x squared plus c. That looks pretty good. All right, so for the next one, maybe it's because like I just did an arc sine problem, but I'm looking at this and I'm like, quadratic in the denominator, there's like only a 1 in the numerator. This is probably arctan. When I think of arctan, I think of 1 over 1 plus u squared. The issue here is that I have a 4 instead of a 1. So what I'm going to do first, before I do anything, is I'm going to take 4 out of everything in the denominator and take the 4 in the denominator is really 1/4 overall, so I'm going to pull that out of the integral. So I will now have 1/4, and then the integral of 1 over 1 plus, and when I factor a 4 out, that's kind of equivalent to dividing by 4, sort of. So I end up with 25x squared over 4. Okay, so that's 1 over 1 plus u squared, which means u squared is 25x squared over 4, so I'm going to say that u is 5 over 2 times x, or 5x over 2. Which means that du is 5/2 dx, but I'm going to bring the 5/2 over to the other side, so I'll have 2/5 of du is equal to dx. And we can make all the substitutions that we need to now. So don't forget there's already a 1/4 out there. And then I'll pull out the 2/5, so 2/5, the integral of, we'll have 1 over 1 plus u squared du, which is perfect because that's exactly arctan. 1/4 times 2/5 is 1/10, so I have 1/10 arctan of u plus c. But remember, we know that u is 5x over 2, so we will replace that, and we'll have 1/10 arctan 5/2 x plus c. All right, let's take a look at the next question, or the next part of this question, I guess. Evaluate the integral of x squared plus 4x minus 3 over x plus 2. All right, so I don't know, you look at this and you're like, if it was reversed, if you flip the numerator and denominator, I would think let's let u equal the denominator and see if it works. It's not going to work. Oh no, that actually I think does work perfectly, but that's not the case. We don't have that problem. What we have is a higher degree in the numerator than the denominator. What you should do in that case is you should always do either long division or synthetic. I'm going to choose synthetic here because it's a linear term that I'm dividing by, and it's just a little easier to do. So I have a separate video, or probably a lot of videos on synthetic division if you want to watch those for how this is being done. I'm going to drop down the 1, multiply, add down, multiply, add down. That's what I've done. And then the whole point of doing this is that our original thing is now equal to, so it's called the depressed equation. It's 1 degree less, so it's 1 times x plus 2, and then minus 7 over x plus 2. That's like our remainder term. So what we're really integrating when we integrate the left side is we're also integrating the right side. So let's actually do that because that's doable. So we want to do the integral now of x plus 2 minus 7 over x plus 2. So you're going to do this process anytime the degree of the numerator is greater than or equal to the denominator. Step 1 is divide somehow. However you choose to do it, you got to divide. Then you can integrate what you get. So I'm going to integrate this. So reverse power rule, reverse a power rule. And then this is a natural log. So it's negative 7, and then the natural log of the absolute value of x plus 2. And then a plus c, because of course. All right, so for the next one, it's like the same thing, and we could do it exactly the same way. But what I'm going to do instead is I'm going to look at this and I'm going to think of, like, what if I turned the numerator into a perfect square? This won't always work. This is going to work in this case. There's almost like nothing that will always work, except for the division thing. That'll always work. But this is called the +1 -1 trick, even though I'm not going to add and subtract 1. I'm going to add and subtract 4 from the numerator. So it's going to look like this. X squared plus 4x, that's the original. Do +4 - 4. I mean, obviously adding and subtracting 4 does nothing, right? Because that's just 0. But x squared plus 4x plus 4 is a perfect square. So I'm going to factor that. And so I chose +4 because it forced the numerator to have x plus 2 squared in it. Because now I can look at this and just cancel it, right? Break up the fraction. So if x plus 2 squared over x plus 2, and then -4 over x plus 2. But in the first part, an x plus 2 cancels, so I'll end up with this. And here, it's basically the same problem that we just did. I'm just going to integrate each part. So reverse the power rule, reverse the power rule, and then we have a natural log. That happens a lot. By the way, when you do division before you integrate, you tend to end up with natural logs somewhere along the line. It's not guaranteed, but it tends to happen. All right, let's look at one more problem. We're going to use the table of values for f and f prime to answer the I don't know what we're doing. To answer, find. Well, let's just find. So find the equation of the line tangent at x equals 4 to g of x, which is f inverse. So this is like your typical inverse problem. So what I always do is I set it up where I'm writing down an ordered pair that's on g, which is the inverse, and an ordered pair that's on f, because those ordered pairs are just kind of like the swap of each other. You switch the x and y. So I know that I'm looking for an ordered pair that has 4 on g, which means I'm looking for an ordered pair that has 4 for y on f. Now I go to the table and I just look for where the y value is equal to 4. I can see that that's here. It's at x equals 6. So the ordered pair for f is 6, 4, which means on g it's 4, 6. All right, so that's like half the setup. And now I'm looking really for g prime of 4. But g prime of 4 will be 1 over f prime of 6. That's why we need to find the corresponding point. It's so that we can set up this relationship. And then looking at the table, f prime of 6 is -5, so this will be -1/5. And then we need the equation of the tangent line. So for the tangent line, I'm going to say y minus 6 equals -1/5 quantity x minus 4. Make sure you use the ordered pair for g of x, the ordered pair that came from the inverse. Otherwise, you'll have the right slope, but you'll have the wrong ordered pair. All right, that's the whole problem set. I hope this was helpful, and good luck.